Alright, let's look at the complex sine and the cosine. Alright, so here's the definition of cosine and cosine. Cosine of z is equal to e to the iz plus e to the negative iz all over 2. And the sine of z is e to the iz minus e to the negative iz over 2I. Right? So those are the definition, and note that z is a complex number, right? But where did these exponential expression come from, right? So recall that we have Euler's formula. E to the I theta is equal to cosine of theta plus I sine of theta. If you take the conjugate of that, you get e to the negative I theta, which is equal to cosine of theta minus an I sine of theta. Right? What we can do is, if you want the cosine, I'm going to add these guys up. So we're going to add these guys up. So you have e to the I theta plus e to the negative I theta is equal to cosine plus cosine is 2 cosine of theta, and these are negation of each other, so they cancel out. And you can see that by dividing both sides by 2, we get e to the I theta plus e to the negative I theta over 2 is equal to cosine of theta. Right? By simply replacing this theta by z, we get this definition, right? So the motivation is there. And also, if you want to find the sine, what you can do is we can just go through a subtraction. So I'm too lazy, so I'm going to ignore this blue part. I'm going to do a subtraction between these two guys. So you have e to the I theta minus e to the negative I theta, which is equal to cosine cancel out, so you have I minus that, so you have a 2I sine of theta. Alright, then we can just divide through by 2I to get e to the I theta minus e to the negative I theta over 2I is equal to sine of theta. Right? So following the Euler's formula, we can see that the motivation of why we define sine of z and cosine of z in terms of exponential function there. All right. So we want to make sure that this definition makes sense with the cosine squared of z plus sine squared of z. We should get 1, right? So let's verify that. So cosine is defined to be e to the iz plus e to the negative iz over 2 squared. And the sine is e to the iz minus e to the negative iz over 2I, then we square that, right? Then this is what we're going to get, right? So square that, you have a e to the I 2z plus 2 plus e to the negative I 2z, right? And all over, and it's going to be 2 squared would be 4, right? And a plus. Alright, square the top, we get e to the I 2z minus 2, then these guys cancel out, and a plus e to the negative I 2z, right? And all over, 2I squared would be, 2 squared would be 4, right? And I squared would be negative 1. So we get that, right? So which means that, so I'm going to actually turn this guy, let's see, I'm going to incorporate this and turn this into a negative sign here, right? So we can cancel e to the I to z minus e to the I to z, same thing. E to the negative I to z, e to the negative I to z, so they cancel out. And you can see that you have 2 over 4 minus negative 2 over 4, so that's 4 over 4, which is going to be 1. Right? So it seems like it carries the property that it should carry. So cosine squared of z plus sine squared of z is still going to be equal to 1, just like real numbers. Alright, so how about the derivative? If you look at that derivative of, so we're going to take the derivative with respect to z of cosine function, which is e to the iz plus e to the negative iz over 2. Right? And if you do that, the derivative of e, so over 2 is just a constant, I just put it there. Derivative of e to the iz would be e to the iz times I plus derivative of e to the iz would be e to the negative iz times negative I. So it's a chain rule there. Alright, so it looks a little bit ugly, so I'm going to multiply top and bottom by, say, let's see, I want to get rid of I. So I'm going to multiply by I here and I there. Right? Then you will end up getting, so on the bottom, you have 2I. Right? So you have I times I is going to be negative e to the iz. And then you have negative I times I is going to be 1. So it's going to be plus e to the negative iz. Alright, if you pull out the negative sign, you will see that e to the iz and a minus e to the negative iz all over 2I, and which is the same thing as negative. So this is going to be, this is the same as sine of z. Right? So you get negative sine of z, which is the derivative of cosine of z. Right? So this makes sense as well. Alright? And so these are the definitions of cosine of z and the sine of z. Alright? That's it. I hope that this was clear.